Hey, welcome back to the Caribou Data Science channel. Uh, as the title suggests, we're taking a little bit of a right turn here. We're going to try to have some fun with some DuckDB and some data from All World and Data. Before we get started, I wanted to introduce you to my new friend, my little friend here, and that is, of course, this right here. Okay, that is a ticket N500T slide rule. Now, if you ever use one of these in the real world, if you ever use one of these things and score on the job, drop a note into below in the comments and just let me know. Okay, more on this later, but well, I'll also mention that there is a international museum online. Lots of free material, lots of slide rules to sell. Um, I got that slide rule from eBay. It was $11 plus shipping and handling, and it came to like $21 altogether, which is probably about what it cost, when it was first made back in the late '70s and early '80s. Okay. So anyway, let's not come over here. So here's the DuckDB website, duckdb.org. Documentation. Let's come over here to this is kind of annoying, isn't it? Let's get a verification code here. Now this is interesting. I don't know where this email is coming from. This email hasn't been active in probably 10 years. That's kind of strange. Okay. Okay. So tonight's mail is going to be coming from All World and Data. So this is over here. Now we can say, how effective are policies in reducing the environmental impact of agriculture? It's over here. And let's see if we can find the data. Let's take a look at this data first. So let's also come over here. GitHub. I prefer underscores so they won't be confused with dashes. Public, create repository. Let's come over here, minimize this, open up a terminal. Okay. Yes, I have in fact found an empty okay. So just for the fun of it, you know how we like Emacs, right? Number of policies in the EU. Huh. Okay. Nothing there. Okay. Okay. Now, where do we begin? Let's begin with okay. And we're looking at 2. So there's actually a newer version out there. Let's just try something. There's actually 10.2. Okay, but okay, that's okay. That's okay. All right. It's over here for the new terminal. All right. So let's try this. Let's do this first. Let's do select star from how's that? What do you think about that? Okay, here, okay. First thing, it's kind of cool, right? Where so let's go ahead. Describe function. Okay. So apparently each country only appears once. And there may in fact only be a single. So the number of policies, what do you have to, so does this mean they've been active 49 49 policies relating to agricultural and so we come up here. All the countries now have policies, and not all work as intended. Some some drive trade-offs or lead to spillover impacts elsewhere. Agriculture is a difficult problem to solve. It feeds 8 billion people, but it's also one of the world's most environmentally damaging sectors. It's the leading driver of deforestation, biodiversity loss, and so forth. Policies that lead to consequences. Agricultural policies can target a range of outcomes. Doesn't tell us exactly how strictly they're enforced. A small, well-implemented policy can be far more effective than 10 poor ones. This intensity-weighted metric is shown on the map below. To account for this, the researchers developed an intensity-weighted metric. This weighs the number of policies by the level of policy stringency. Okay. So we could do things like, let's do some of our favorite statistics here. You notice what's nice about DuckDB? It has completion, has command completion. Let's abbreviate this as this policy. Okay. Now here, see we have a built-in median function. This is the only database I know that actually has this, okay? There is one other thing you can see in a moment also, okay? And of course, median is a really good statistic. It's used a lot. We have a lot of outliers, okay? So that's kind of curious, isn't it? Did I do something wrong? That doesn't make any sense. Because if you look up here, because you look up here, you can see that some of them don't have, or not 49. Well, that's interesting. Why are we still? Well, that's interesting, isn't it? Come all the way back up there. Here we go. Don't know how that happened. Okay, good. So now let's come back over here and let's take a look at most of them aren't. Let's get back to the. Now we got something to look at here. Okay, good. Minimum policy is 1. Maximum policy is 183. Wait a second. Median policy is 14, and the average is 28. So let's ask ChatGPT about these two numbers here. You know, what's interesting is, we have some more statistics, don't we? We have Katosa and skewness also, don't we? Okay, now here's the thing. For me, that median function really is a game changer. Plus, like I said, as you'll see, it also has Katosa and what else? Katosa and skewness built into boot, okay? $14 and $28. How could someone 107 policies? All right. Positively skewed. I would say that's probably certainly compared to 183. See, this means that there are likely a few very large number values that are pulled mean upwards. Good. Why can't you display plots? Because we're not using ChatGPT 4. All right. So anyway, okay. So now let's come back over here. Documentation. What we're looking for here is the statistical function. Hmm. Look at all these functions there. 2 days, 2 decades. That's interesting. Oh, shoot. Let's go over here. So this is the median. Let's find out. Now I think we need a halving. Well, what we can do is we can just get lazy. Is less than. Okay. You can see there's a lot of the ones that are there's 106 rows with the number of polys's inactive less than the median. What about greater than it? 104 rows where the numbers are greater than this. So let's try this. Let's try a limit of 10. Okay, so this is the top 10 people who are countries who have enacted more than the median number of policies. Well, and the thing is, I'll say is You can do a whole lot of data analytics using SQL, and even more data analytics using DuckDB with some of the additional statistical functions like median. Let's just try asking ChatGPT. Okay, so let's come back over here now. Let's get rid of this. I forgot about it. I forgot about the. Okay. So all you got to remember is okay. The kurtosis value of 3.439 indicates that the distribution is leptokurtic, meaning it has a heavier tail and sharper peak compared to a normal distribution, which has a kurtosis of 3. a heavier tail and a sharper peak. This suggests that the data has more extreme values, both high and low, and can be expected in all distribution. Leptokurtic distributions often have higher likelihood of extreme events. A skewness of this of 1.957 indicates that the distribution is positively skewed, and meaning it is skewed to the right. This suggests that there is a long tail on the right side of the distribution, skewed to the right. So when it says skewed to, that's the direction the tail is, okay? This suggests that there is a longer tail on the right side of the distribution. The bulk of the data is clustered around the left. Positive skewness can be caused by outliers. So we have positive skewness. All right, good. And so the Katosa 3.439 suggests that the distribution is leptocatonic. Let's try one more thing. It's just equal to 4. This is where Quote comes in really nice. It can actually draw pictures sometimes. Okay. And there you go, my friends. A brief look again at DuckDB. I need to spend more time with DuckDB to really find what they also allow you to do is you also have the functions built into the core language to calculate quantiles. Now, I know with the SQL Server, you can in fact calculate quantiles, but they have to be done as part of as a part of a window function. In DuckDB, the calculation for quantiles are part of the core language, just like median is. I mean, you can execute them just as you would any other function. I got to find that. But I hope you found, as always, like I say, all the cool kids use DuckDB to do the data analysis with. Okay. Thanks so much, folks. Of course, subscribe, click the like button, and share the stand over. And share the love and share the